Hi, my name is James McNamara. I'm the Director of Product and Solutions at Zinkworks. We are a 250-person engineering company in Athlone in Ireland. We focus mostly on telecoms and financial services. One of our primary value propositions is we deliver complex solutions for our customers, primarily in the autonomous network and OSS space. So be it migration to cloud infrastructure off-prem or simplifying OSS landscapes, that's effectively where we operate. Our journey to our apps started pretty much 2 years ago. Our innovation team started playing with the EP5G APIs. We just started tinkering around with them a little bit to see what we could do. And I think like a lot of companies that started looking at private networks, we ended up exploring ports and port use cases. One use case we really focused in on trying to solve was that one around, mobile infrastructure, mostly like gantry cranes. Could we solve how they would infringe on their SLAs when they try to move around the urban canyons created by the stacked containers in a port? So one specific thing that popped up quite a bit was when gantry cranes were trying to unload ships. They'd all coalesce around that ship. There'd be latency issues that could pop up. And we thought it'd be super useful if we could use AI to try and predict A, where devices would appear on the network or where they would move around physically, and B, if we could predict the traffic that they would use when they get to that specific location. And then we could offer guidance to the network orchestration functionality to try and better manage that problem. So that was fantastic. We did quite a bit of research on that. We developed some AI applications, but we didn't really move too much forward on that with the networks. However, during our research phase, EIAP came into existence, and that offered us a really interesting way to take our AI algorithms, which was our focus area, and get them to market. So we could package them up as our apps and offer them through that marketplace to customers. So what we did was we packaged up two of our primary applications, which was our network traffic prediction application and our position prediction application. So NPP and NTP, and I'll talk about those in a second. Secondarily, then we have QoSP, which was affecting change on the network based on the prediction. So specifically, in the case of the port, the challenge was the quality of service and the quality of experience at the device level. Could we directly impact that? So we've actually a prediction model built around solving that situation as well. So I'll talk about QoSP and PMC as well. But the way we have a catalog developed at this point of AI applications, and the way we've segmented our portfolio is we have foundational applications, so ones that are core prediction engines that enable further use case focused applications. And then we have the application focused, use case focused apps as well, like quality of service prediction and power management controlling. But yeah, I'll go through them in a little bit more detail. The first one, this is probably our most important one. It's our NTP application. So NTP is traffic prediction. So this is where we use an LSTM model combined with a graph neural network to ingest PM and FM data directly coming from the EIAP APIs to predict traffic congestion on various locations and various cells. This would be probably our most fundamental application, enables a lot of other applications and use cases. We've actually gone ahead and patented this application recently as well. So the key here is to try and achieve performance better than you would have historically achieved with some more traditional models like autoregression, to try and solve these use cases. I'll talk a bit more about how these all tie together in a moment. But this is the second one I spoke about when we were looking at private networks, was the idea of position prediction. So this has two pieces to it. So the first one is improving position prediction or position accuracy. So the inputs to this model are both GPS and the signals coming from the 5G network as well. So we have both a combination of the GPS signals and the things like angle of entry and exit and so on. So our model ingests those, and then it processes them to simplify and clean up the signals So we can, let's say, categorize line of sight from non-line of sight signals to get a better indication of where the device is in a specific area relative to a specific cell. And that enables us then, once we have that clarity on the position, to predict which position it will be in the future. So the idea here is if there's UEs or devices moving across the network, we can predict where it will be in the future. And if we can predict the load that will be on a specific cell based on that, those two together give us a great foundation to be able to do things like modify the quality of set and profile on the fly, which facilitates a lot of use cases around industrial robotics, or even if we move in towards probably CV2X and autonomous vehicle use cases as well. And this is probably the first of our use case focused applications, the quality of service prediction application. So again, this is based on the NTP application. So we have this logic in our portfolio where we do our app chaining. So we have the baseline ingestion layer, which there's generally an RApp that does some level of KPI and counter ingestion and normalization on those inputs, which feed into an enablement application like the NTP or MPP prediction algorithm, and they in turn feed into a use case application. And it was actually quite interesting listening to Rob yesterday when he talked about how we potentially could work with Ericsson to abstract all that complex, but probably heavy and not required logic into the actual service layer and avoid having to replicate it each time in the algorithms. But nonetheless, so that's what we do here. So this is, again, so we ingest the data, we use our NTP algorithm to indicate if there's going to be congestion or traffic on a specific location on the network, and then we can offer guidance back to the network on how to handle that. So make policy suggestions and so on. And finally, we like I guess everyone else, we have a power management controller or app. This here is where we use a fusion model combined with our LSTM and GNN models to enable the switch on and off of carriers in a specific cell to achieve power saving benefits. So this was quite interesting. We entered the 2024 fall Oran Alliance Plugfest with Ericsson, where we deployed NTP and our power save management controller application into EIAP and presented it at that event. And that was quite fun. That was really interesting. We went into real integration and deployment of the platform there and showcased it in an independent lab. So yeah, I got very familiar with the process of integrating our apps in real life through that process. So I have a couple of screens here as well, just to show what we've created a demo site just to simplify visualizing what these applications can do. So what we do, this screen is just picking a cell, and in here we show what our prediction looks like. So this is running off. We've a quite advanced simulator at this point. We've been working on it for 2 years at this stage, where we simulate data coming into our applications as they would on a live network. And you can see there the up and down line is the actual network, and our algorithm then is the straight line predicting in this case down, but predicting in the future. So in 15-minute segments. Obviously, the more data you provide to the model, the longer we can bring this prediction line out, so we can actually predict further in the future. It depends on what the customer wants and the data access that we have and so on. Similarly, just a quick little demo on the same set of cells for the power management controller. This here is quite interesting. We had a bit of fun with this one. This was a little bit more advanced in the development because it was for the Plugfest event. But again, it's predicting the usage or the power consumption. So we can see here as the actual spikes from the simulated data are displayed, our estimates align as well. The idea here is we have an eco mode option here, which is effectively how we can switch on and off the carriers dynamically, so we can save power. And I guess just a quick overview of the journey so far for Zinkworks and our apps. So as I said at the start, our NTP application, which is our foundational application, we secured a patent on that last year. We presented NTP and MPP and QoSP at MWC in their more nascent, unintegrated form last year. But since then, we've integrated them to the platform. We've added our first applications to the directory, so they're available there now to view and to explore with us. We participated in PlugFest, as I said, and then we are in discussions with a US and an EU carrier on actual purchase and deployment of 2 applications. So that's really exciting for us. It's great to, I guess, move from R&D and innovation into actual deployment and delivery. So it's been a pretty cool journey, and I guess one of the interesting things on our journey has been that as an actual development rApp vendor at this point, we also are a large software company. As I said, we have 250 engineers available. So one of the things we look at is trying solving our own problems. So one of the things with our apps, we're still developing the tool chains, and it was quite interesting to see, could we ourselves develop tools to enable faster development of our apps within our own teams. So I guess that coincided with the development of Gen AI and the availability of Gen AI, and we work quite a bit with Google as well. So we developed a no-code visual editor for our app development. So the idea with this tool is you can, let's say a RAN engineer or someone's familiar with the actual data themselves, can pop in here and actually develop AI-based algorithms pretty rapidly without too much need of a large support team to develop it. So what you have here on the left is effectively what's exposed through APIs. You drag and drop them onto the editor. You drag on some model. You can do some meta configuration on it, and you decide what your output's going to be. When you press build on this, it effectively goes and builds this using Gen AI. So and behind it has Gemini, and it's using BigQuery models as well. And it spits out a CSAR package, which can then be uploaded to EIAP. So quite a neat solution for rapid development of our apps, because effectively this is a new technology. So the need for rapid iteration and fast development is quite important. And I guess as we are an rApp vendor, so because we're an rApp vendor ourselves, we understand that these are quite intensive with their need for manpower, but nonetheless quite small teams supporting this. So so the ability to use no-code Gen AI is quite powerful here. That's it. Thanks very much.